How many covalent bonds does carbon want to make? 4. All right. And how much does each of the oxygens want to make? 2. All right. So let me put that up first. Or actually, no, it's all right up. So tell me. So how are you going to make? Are you going to make it fly? 2 double bonds. That's exactly right. So let me show you what that would mean. Thank you, Taylor. All right. So this, if you like, this wants to make 4 covalent bonds. These each want to make 2 covalent bonds. Right? So you can put these things together and make everybody happy if you make a structure like this. You got your 2 lone pairs on the oxygen, and what you put between is now 4 electrons. Well, like Taylor said, it's what's called a double bond. This is, and you can write this as O with its 2 lone pairs, double bonded to C, double bonded to the other O. And this thing is a double covalent bond. That's these here. There's, okay. And they are 4 electrons shared, therefore stronger than a single covalent bond. Right? So Taylor's got it exactly right. And a way to look at it, so if I'm a carbon atom, I got 2 arms to hold on to something and 2 legs, 4 places to bond. Oxygen's got 2, so one oxygen grabs my 2 arms, the other one grabs my 2 legs, and everybody's happy. I'm making 4 bonds. And if you count the electrons around the oxygens, there's 2, 4, 6, 8. Carbon's got 2, 4, 6, 8. Other oxygen's got 2, 4, 6, 8. Everybody's happy. And those bonds are stronger. Why are they stronger? Because instead of 2 negative charges gluing us together, you got 4 negative charges pulling us even tighter in. Okay. Question? Yeah. Oh, why? Oh, yeah. So that's actually a really good question. I'm glad somebody asked that. Like, wait a minute. Those lone pairs were sort of top and bottom, and now they're like at 2/3, a third of the way around. It turns out, it's hard to know what matters and what doesn't in chemistry. It turns out the exact location of those doesn't matter. As long as oxygen has 2 lone pairs and makes 2 covalent bonds, whether you draw it as covalent, lone pair, or like some sort of, some bent thing or whatever, it turns out not to matter. The geometry will matter in more complicated molecules, but it turns out it's okay that those got moved. Right? So if you were thinking maybe that oxygen can only do this, then you don't know how to join it to carbon. It turns out you can bend them around. There's some flexibility. That's a good question. Other stuff. All right. So let me do another example, but I won't ask you all to do it. If you do let me write that more neatly, please. HCN, hydrogen cyanide. Right? This thing wants to make 1 covalent bond. Carbon wants to make 4, and nitrogen wants to make 3. You can make everybody happy very simply if you make this molecule. Okay. This guy is a triple covalent bond. That's 6 electrons are shared, and it's stronger than a double bond. Okay. Is it 3 times as strong as a single? No, it's slightly less than 3 times as strong. Okay. Is it 1.5 times as strong as a double? Not quite. It's a little bit less. But you got a serious cloud of electrons. It's significantly stronger than a double bond, right? And you could do that. Turns out, I think they've discovered, not with molecules like this, there are some quadruple bonds. Those are extremely rare. We will never meet them in Biology 111, and that's about as high as it ever gets. All right, questions about that before we move into some deeper water? Yes? How do you know what order they go in? Tell me what you... it turns out in this case, if you tried to put them as like NCH, it's not going to work. If you follow, how would you figure this one out? You follow the rules. Hydrogen makes 1 bond, carbon makes 4, and nitrogen makes 3. You could try writing them in different arrangements. There's only this one that makes everybody happy. So in this case, the way I wrote it is the way you draw them out. Sometimes it's not so simple. With simple molecules like this, yes. More complicated molecules, it's not always quite that simple. But even if I wrote it weird, like NHC, you could, if you drew it out, there's only one way they'll work. All right, other questions? Yeah. So you get this by knowing that hydrogen makes 1 covalent bond, carbon makes 4, and the triple counts as 3 of those 4, and nitrogen makes 3, and it's making 3 bonds. So nitrogen connects, has 3 bonds to something else. Carbon makes 4, 3 to the nitrogen and 1 to the hydrogen, and hydrogen makes 1. So that follows the rules. Okay. Yeah. Will it be given to you like on the exam how many bonds each one makes? Yes, I could give you that. By the time you're done with this, you'll know there's only so many atoms and it'll be pretty familiar. But on an exam, the last page would have that information. Yeah. Oh, is it safe to assume there's 2 electrons in the inner shell of every atom? Yes, it turns out to be so. All right, so let me